All right, so last video was horrible. This video I'm going to try and make better. Got the camera closer here. I'm going to have to move it a couple of times, so bear with me on that. But this is the 1.3 task. This is essentially your notes. We're still looking at comparing and contrasting linear and quadratic functions. In this example, Scott has decided he really wants to start getting in shape. So he's going to head to the gym and do some push-ups. So he's going to keep track of how many push-ups he does in a given month, and he's going to model that off of the diagram there that you see in your notes, which is right here. Day 1, he's going to do 3 push-ups. Day 2, he's going to do 5, and so on. Based on that, we need to fill in the table, and we need to draw a graph and create an equation to model that. So my question to you is, go ahead and pause the video and fill in the table, because I'm going to go ahead and fill in the table right now. Take a chance and see if you're going to do this right. Remember, n is the number of days, f of n is the number of push-ups. So pause and see how you do. All right, you should have gotten days, which is 1 through 6, even though there's only 4 days in the diagram. The number of push-ups, 3 on day 1, 5 on day 2, 7 on day 3, all the way to day 6, which gives you 13. And your first difference shows a difference of 2. If we're going to graph this function, we should be able to fill in the title or label, not number, label my diagram. What do I label the x-axis? I should label the x-axis days. I should number it 1 to 10. Pause if you need to do that. And also, quickly before you pause, think about what I'm going to title or label and number the y-axis. Do that real quick. Okay, we're going to label it number of push-ups, and we're going to number it. In this case, I numbered 2, 4, 6, 8, 10. I don't really want to number it 1, 2, 3, 4, 5. I don't think that's enough. You could number it by 5s, 5, 10, 15, 20. Either way. All right, so we have both of our axes labeled and numbered. Think about what the graph of this is going to look like. Think back to the diagram. What's it going to look like? Well, 1 is 3, 5, 7, 9, 11, so hey, there we go. It's going to look like a straight line. It should. Now, as far as the explicit equation to model this, what's it going to be like? Well, we know it's linear, so it's going to be based off of y equals mx plus b. What is m? M is the constant rate of change. Based on your difference, you already know that. You know that it's y equals 2x. The only thing I have to figure out is, what is b? B is the y-intercept. You can figure that out one of 2 ways. Either looking at my graph or looking at my table. It's not as easily seen in the table yet, but it's there. If you look at your graph and you've graphed it correctly, follow this on down until it crosses the y-intercept. What is that number right there? That number right there should be 1, which tells me this is plus 1. If you look at your table, my input should be 0. Where is my input 0? Well, it's not there. You're right, it's not. I have to work backwards to find it. And an input of 0, what should my output be? Well, if it's plus 2 plus 2 plus 2, then the reverse of that would be minus 2. 3 minus 2 is 1. So that tells me there's my explicit equation for that linear function. All right, take a minute, pause the paragraph at the top of the next page. I want you to read it 3 times. I want you to read it through once. I want you to read it through again. And on the 3rd time, you're not necessarily reading it, but I want you to circle some important information. Do that now, please. All right, coming back. You should have noticed that 500 push-ups is important, and every extra 100 push-ups is $10. Those are 2 important pieces of information. Question 2, estimate. In a second, I'm going to have you pause the video and estimate what the total number is that he will do in a month. And this is just a guess. You don't have to be right. You don't have to be wrong. Okay, it'd be great if you were right, but as we were in class most of the time, we were wrong. Just estimate the total he's going to do in a month. And how do you back that up? I got a bunch of different numbers. I got 75, I got 61, I got 60, I got 65. A lot of students were basing those off of the previous equation over here, 2x plus 1. And they were saying, well, if he's going to do 13 on day 6, day 7 he's going to do 15. So 15 and 15 is 30, 30 and 30 is 60. So that's how I base it for the month. Okay, my thought process personally, my thought process was this. I went out to day 10. If I can follow day 6, 7, 8, 9, 10, by the time I got to day 10, he's going to do 21 push-ups. Okay? So I'm just going to double that for day 20 and triple that for day 30, knowing that he's going to do a few more each day. So by day 20, this might be 42, and by day 30, maybe it's a little on the high side, somewhere between 80 to 90. That was my thought process. That's just kind of what I did, right? And whether you're right or wrong, again, that was just a thought process. But keep in mind, he's doing that for, we want to keep track of how many he's doing for an entire month. So now, what we're going to look at is it wants us to draw a diagram for the total number that he's done. And you have 7 days down here. I'm going to show you how to do the first few days, and then you're going to have to pause and do the rest. Day number 1 should be exactly like the diagram we have over here. Start in the lower left, please. You have 3 bars. We're going to fill those in. Okay? You can color them in nice and bright if you want, whatever, just pause it. Day 2 should be a repeat of day 1, but including day 2. See how it's a repeat of day 1 plus day 2? It's got those totals there. I did 3 the first day, I did 5 the second day. Okay? Day 3 is going to be the same as day 2, which is, here's day 2, but now I'm going to also add 2 extra. Right? So continue that till you get to day 7. All right? So you want to pause it and continue until you get to day 7. It's going to take you a little while. That's okay. Draw it out. I know. You'll see the evidence of this when we come back to it here in a little while. So go ahead and draw all those days out. Right? And by day 7 you should have this. Did you pause it? Did you draw all those out? I'm telling you, draw them all out. If not, pause again, draw them out. Question number 4 says, how many push-ups did he do in a week? Total for the week. Remember, how many did he do not just on day 7, but day 6, day 5, day 4, day 3, day 2, day 1. On day 7, he should have done 15 total. On day 6, he did 13. We can look at our chart and see that. On day 5, 11, 9, 7, 5, and 3. So what do you think I have to do with these numbers to find out the total he did for the week? 15 plus 13 plus 11 plus 9 plus 7 plus 5 plus 3. I've got to add all those up. Remember, this is day 7, day 6, day 5, day 4, day 3, day 2, day 1. How many did he do total? If we count all this up, he did 63 total for the week. If I want to estimate for the month, well, gee, here would be 63 in week 1, 63 in week 2, 63 in week 3, 63 in week 4, 3, 6, 9, 12. 6 times 4 is 24, 25. 252, roughly, about that. That's the wrong approach, though. Remember, we're missing the idea. How many does he need to do in order to be able to have money donated to charity? It doesn't say how much money. It just says money. He's got to have 500. Even if 252, it's way off. All right, so let's look at what's going to happen later down the road. That's just question 4. We have a few more questions to answer. Okay? So it wants us to model some other stuff that's going on here. What are we going to model? Well, our first equation was a linear function. right? That was plus 2, plus 2, plus 2, plus 2. What do you think is going to happen here? Well, it shouldn't, I mean, if you've been in class, or even if you haven't been in class, what have we been modeling? We've been modeling linear and quadratic functions, so we're comparing. It could be that this is a quadratic function, and you have a pretty good idea it's going to be because we have a second difference over here. But look at our chart. Now understand the chart. It still deals with days. Okay? F of n, which is the first function we dealt with the number of push-ups he did on a given day. That was 3, 5, 7, 9, 11, and 13. This other function, m of n, completely different function, is asking for something completely different. How many did he do total? Well, on day 1, he did 3 push-ups, so total he did 3. On day 2, he did 5 push-ups, but how many did he do total? 5 plus 3, which is 8. On day 3, he did 7 push-ups, but how many has he done total? 15. Day 4, he did 9, but he did 24 total. See the connection here? 3 plus 5, 8 plus 7, 15 plus 9, 24 plus 11 should be 35. 35 plus 11 should be 48. Okay? Hopefully you see that connection there, how that worked out. Now, first difference. Is there a first difference? Well, 3 to 8 is 5. 8 to 15 is 7. 5, 7. The next one's going to be 9. The next one's going to be 11. The next one's going to be 13. See how we're seeing the linear total come out here? And then our second difference is plus 2, plus 2, plus 2, plus 2. What do you know? This was the constant difference in our first set of data, all right? But that linear pattern came out here, and it repeated itself here. Now we have to graph this data. Label, label. I'm still labeling my x-axis the number of days. I'm still numbering it 1 to 10. Again, if I'm going too fast, pause, catch up. All right? Pause it and catch up. How do I label my y-axis now? I don't label it number of push-ups. I label it total. Total push-ups. So how am I going to number the total number of push-ups? Well, now it starts at 3, but it's 48 and it keeps going. So I might go by tens. If I go by tens, I'm going to get from 10 to 100. That's reasonable. Yeah, I know day 1 is small. And remember, this has a second difference, so what should my graph look like? When I draw it, what should it look like? Yes, it should look curved. Try and plot these points. Remember, you're not using this middle portion of data for this. It's total number. You're using the days and the m of n function. M of n. That's what you're using. So pause and do that real quick. Okay, you paused it. You should have plotted these points real quick. And you should notice my data's curved. Okay? Now, the other thing we have to do is we have to create the explicit equation. How am I going to create an explicit equation for this information? I'm going to go back and I'm going to use my diagrams from the previous information. I'm going to use these diagrams over here, right? And then I'll be able to do that. Now, pay attention. You might get this, you might not. But we want to look for patterns. We want to notice things that are happening. What I notice here, and again, I can just rearrange to try and help myself out. What I notice is that this is a rectangle that is 1 by 1 plus 2. I can take this second diagram and I can move this one block down here, and I can create a diagram that is 2 by 2 plus 2. It's 2 wide by 2 high plus an extra 2. I can do the same thing with this block, and I'm only going to use the first three. I have 2 blocks here that I'm going to put over here. And when I put those over there, this is going to be 3 wide by 3 high plus 2 extra blocks. And you can see that that pattern is going to continue. 1 by 1 plus 2, 2 by 2 plus 2, 3 by 3 plus 2. So if this pattern happens, for any given figure, it should look like this. It should look, for any of these given figures, it should be n by n plus 2. Remember, we do things by multiplication. Length times width or base times height. It doesn't matter how it's done. N by n plus 2. Width, height, width, height. I'm always going to be adding, the height is always going to be 2 more than the width, essentially. And we take that, and when we multiply it, we get or n squared plus 2n. This is my explicit equation. Now that's tough. I get you. That is difficult. That's not something you're going to grasp very easily or grasp every day, and that's completely fine, right? Getting all of this other stuff is a goal that we can have, so at least we can see what's happening with the data. The equations will come later on themselves. So if we have a n times n plus 2 situation, is he going to meet his goal? And this would be m of n. Is his goal going to get met? Remember, his goal is to do 500 in a month. 30, 31 days, I really don't care how you look at it. Let's look at 30. If 30 is the day you have stuck in your mind for the number of days a month, 30 plus 2 is 32. 32 times 30. What is 32 times 30? Well, 3 times 3 is 9. So 32 at 6, that's 960. Okay? And all I did was I multiplied like this. I did 32 times 3 essentially. Okay, 3 times 2 is 6, 9, and I brought down a 0. That's how I did that fast. What if 31 is your fancy? If you have 31 plus 2, because I got to put 31 in here, then that's 31 times 33. I don't have anything fancy for that because it's not a multiple of 10. But you get approximately, in my notes here, I have it in my notes, I think it was 1023. Okay? He did more than 500. That's going to be the total number he's going to do in a month. Right? So he did plus the 500. So if we take the 500, 100, that's 600, 700, 800, 900. He's going to earn an extra 10, 20, 30, 40, an extra 40 plus 50 bucks, somewhere about an extra 50 bucks, plus on top of what charity's going to give him is what he's going to earn. Right? So did he meet his goal? Yes. Takeaways. Let's look at some takeaways from this. What are our takeaways from all of what we did? Keep in mind, how many differences do quadratic functions have to have? 2 differences. Okay? So second diffs and parabola or U-shaped graph. Just again, U-shaped graphs. That's a couple of takeaways. It's a couple of quick ones, right? It seems like the same thing, but we're trying to model. I'm trying to get you to think about how the data is represented, and I get you. Right over here, this is the toughest part of the whole entire lesson right here, right? How are we doing this? How did I do this? I started off and I said, okay, well, I know that on day 1 he did 3 push-ups. And I based everything off of y equals x squared here. This is the function where I start. That's the beginning. That's the building blocks of what I'm doing. Just want to make sure that this is in the screen. So I'm basing everything off of that. Well, I said if my output has to be 3 and my input is 1, 1 squared is 1. What do I multiply by 1 to get to 3? I multiply it by 3. So I said, okay, y equals 3x squared. I question, is that correct? Well, I know it works for number 1, but what about 2? 2 squared is 4. 4 times 3 is 12. My output is 8. 8 does not equal 12. So that's not a valid function. Y equals 3x squared is not valid. But I know it's got to have an x squared in there somewhere. Well, the second part of this was linear. So I looked and said, okay, how about x squared plus 2x, or n, whatever you want to call it, because this is the kind of the beginning portion of that linear function that we have over there. And I just went ahead and said, okay, if I'm going to put 1 in here, 1 squared plus 2 times 1, what's that going to be equal? It should be equal to 3. Well, just so happens 2 plus 1 is 3, 3 equaled 3. Yeah, that checked, but again, is it going to work for the second day? Is it going to work for day 2? 2 squared plus 2 times 2. See how we're getting this information from here? 2 squared plus 2. 2 squared plus 2. 1 squared plus 2. It's exactly what I got up here. 1 squared plus 2. 3 squared plus 2 would be the same thing if I put in 3. So it's actually easier to try. It's a fight, but it's easier to come up with a model that way. All right, I'm done. Thanks for watching.